Assalamu alaikum warahmatullahi wabarakatuh, everybody. I hope you are having a good day. This is me again, Dr. Hayam from UMB, University Malaysia Bahang. We are continuing our course Microcontrolling Start as Professional. In this video, we are going to speak actually about the hardware and software in more details. So last video, Mr. Hassan gave you introduction about the laboratory that our students using in UMB. But actually, no need to have very professional laboratory to do simple projects. So today, I will speak in details about the training board and the programmer, the compiler and the simulator, the two programs that we are going to use. So we are going to use two programs or softwares, one to do the compiling and to upload the code that you write using your PC computer to the microcontroller. I will speak about these details. Then we will speak about simulator, how to do simulation before implementing your code on the real hardware. I will speak also about the AVR Studio, which is like the compiler and the builder and the main program that we are going to use in this course. So let's start with the training board and programmer. So there is no one special training code for AVR family. Just go to Google and write AVR training board and you will find a lot of variety. So in this course, as Mr. Hassan showed you last time, we are going to use these two devices. I will move now to the other camera and explain to you what is these two devices and how to connect them. So as I said, these are the boards that we are going to use. This is our training board. So as you can see from this training board, we have, this is the microcontroller. Okay, so this is the microcontroller. This is at Mega 32. It's connected here to this board. So this actually is the training board. We use the SKT16. So it's using what's called the ISP6. So this is ISP6 which is used. This is the microcontroller. This is the device that we are studying. Okay, so this is just a board to facilitate using this controller. So as you can see here in the board, we have these buttons. We'll use these buttons for input. Here we have LEDs. Okay, so we have L0, L1, L2, L3 up to L7. This will be connected to the boards, as I'll explain later, to show the output. The buttons will be used for input. So as you can see, the pins here, so this pins actually is connected to here. So when we put the microcontroller like this, okay, so make sure this half circle is to a board and then we close over it. Okay, so now this microcontroller is connected to this area, and we have the these pins, all of them is connected to the pins here. So as you see here, this is AC0 and BA0. It's the same pin like pin number 1. Okay, we have here the jack for the power, and we have for serial, we have here 5 volt and 0 VCC and ground, and we have the crystal. This is like to giving the pulses, the clock. And we have reset button, so in case you need to reset your program, you push the reset button. Okay, so this is just a training board to facilitate using our microcontroller. The other device here is the programmer. Okay, so this is our programmer. Okay, so as you can see, this programmer is connected through this 6 pins. So this 6 pins is the ISP. It's connected here. Okay, so it's connected to the board here, as you see, like this. Okay, so we connect here. Okay, so this is the programmer. Actually, we connect here through the USB. So as you see, you have a USB cable. Okay, this USB cable is connected here, and from the USB cable to the laptop. Okay, so as you can see here, we connected to the laptop. Okay, this is very important. From the laptop to, or any PC computer, to the programmer. Okay, so from the laptop to the programmer, from the programmer to the board. Okay, so actually when we write a program, as we will see later, using the PC, then we compile it. I will explain what is compiler. Then through the USB, the compiled program will go to the programmer, then from the programmer it will be uploaded into our microcontroller. So this is our device. We use the laptop just to make the code using assembly or C, then we move to microcontroller. Then we can disconnect everything, and this microcontroller is a standalone computer to do the controlling elements. Of course, we need to give power to this device. So to give the power, we can use a plug like this one, okay? When we connect, it's like giving 5 power, or we can use the power from the computer. So we need a USB cable, another USB cable, with this one which is suitable for this jack. So we connect here, okay? So we connect it here, and we connect the other side, the USB, to the USB plug, okay? So USB plug can be connected here, okay? So important, this is power, okay? There is no data here, so I can connect this plug and the jack here to power, okay? So I can connect here. This is power. No need to have a computer. But the programmer, this one, the programmer should be connected to the PC, okay? So as you see, the programmer is connected to the PC. So like this, we have our devices ready to be used, okay? We have the programmer. We have connected correctly to the board. The board is getting power from here, okay? And the programmer is connected to the PC, where we will write our program and upload it, okay? So now let's go back and see what kind of programs we are going to use. So after connecting our training board and programmer, so we are using programmer USB AVR ISP XP2 and training board SKT16+. Of course, this is not necessary to use the same. You can use anything similar, but the idea, you should have a training board. The important is to have any training board that is suitable for Atmega 32, okay? And to have the programmer, the USB programmer, and connect them together. So we are using the ISP connection. Next, we need to understand how to use the PC, the computer, to write a program and compile it. So we need to use a compiler and upload it to the microcontroller. Or we can use another software, not to upload to microcontroller. We can use a simulator to see how this is working. So let's see what's the compiler. Let's speak about compiler. So a compiler is a special program that processes statements written in particular programming language and turns them into machine language or code, okay? So what is stored inside the microcontroller is the code or the machine language, but what we write on the PC is a programming language, even assembly or high-level programming language, and the code or the machine language is the language that the processor uses. Simulator is something different. It's another thing. It's not actually related to the microcontroller. It's another software to make it easy for us to understand how to use the hardware. So we make sure that our program is working, then we apply it on the hardware. So simulation software is a handy tool to test programs and embedded design for electronic before applying it on hardware. Okay, so we need to see our program is working before uploading it to the microcontroller. We use the simulator. So in early stages of program development, simulators are executed on general purpose computers to simulate the instruction sets of a microcontroller. So simulator is like separate from the microcontroller. It's run on the PC. So in this course, we are going to use AVR Studio as our IDE, which is Integrated Development Environment, which is our compiler. Okay, so the compiler is AVR Studio. The output of this compiler is even go to simulator or go to the hardware, as explained later. For simulation, we will use a program called Brutus. Okay, so now we will start speaking about the AVR Studio, how to use AVR Studio to write simple program and how to compile it and prepare the file, which is including the machine language program. AVR Studio is related to AVR family. Other microcontrollers have other softwares, because each family of microcontrollers have its own unique type of hardware architecture, instruction sets, register configuration, and memories. So when we study the ISA, we study all of this. We study the special commands or the special instruction for this microcontroller, and we need to use them in the correct IDE. So for each architecture of microcontroller family, there will be at least one compiler available supporting that particular microcontroller family, or a couple of other family. Not necessarily the same. There are kind of general compiler that is suitable for many families. Many of these compilers support programming in assembly language. Some of them support programming to be written in C language. So basically, microcontrollers, all of them will take assembly language, and all of the compilers are supposed to support the assembly language. Using AVR, so we are going to use the software called AVR Studio, which is support AVR series microcontrollers. This IDE has been designed by the manufacturer of AVR, which is Atmel itself. So it's designed by them. So we can say the default or the original or the standard one for AVR. We are going to use what's called the ISP programming. So ISP Programmer, the one that I already showed to you, we are going to use it for Atmega 32. So Atmega 32 series microcontrollers support three types of programming actually. They are support parallel programming, ISP programming, or serial programming, and there's what's called the programming via JTAG. So we are going to use ISP, which is stand for In System Programmer. AVR Studio is supporting the include, which is used in C language. This include actually have a lot of important information. So you need to include the correct file for your microcontroller. For our microcontroller, we are using Atmega 32. So the file that we need to include actually is m32adif.inc, and we use the command .include. So this is in assembly language, not all assembly language, I mean not standard assembly language, is for only for AVR. So this actually include all the important information that we are going to explain later. For example, how to use this, as I said, like if you remember when I speak about the memory, so we say the memory have like the first part is for registers, the second part is for input output ports addresses. So actually no need to worry about this. As you will see, no need to write the addresses, which is numbers. We just write like this because inside the include file we have this information. So this was just a quick introduction about AVR Studio. In next video we are going to introduce more details about how to use AVR Studio, and we are going to do a simple example using assembly language and using the microcontroller. Thank you very much for listening.